Alright, let's do this question. You're given a slope of 12%. Given. It's not from my notes, it's separate questions. Given slope is equal to 12%. Ground speed is 540 knots. Find ROD.
Slope 12% or degrees?
Percentage.
Okay.
Yeah, so
that is basically the gradient.
That's right.
Okay.
So when you see it in percentage, it's basically it's gradient. You can take it.
Okay.
So yes. So here you can see you have given a slope, you have given ground speed. You're asked for rate of descent. You have the straight equation here, right? Where you have the percentage gradient expressed as a function of ground speed and rate of descent. What is that?
Yes. That gradient in percentage is equals to ROD in feet per minute divided by ground speed in knots.
In knots, straight. No conversion, nothing, because you've already taken that approximation here, where 1 nautical mile is equal to 6,000 feet. Alright. Now, if you take this approximation, then the answer is pretty straight here. Percentage gradient is 12%. What is rate of descent? It is, you have to find it out, and ground speed is in knots, and therefore rate of descent is equal to
6480 feet per minute.
Yeah.
Okay.
6480.
That's a huge ROD.
It depends upon type of aircraft and stuff. So fighter jets, the different aircraft have different capabilities. Yeah, so not for commercial aircraft. Shown A6480, and you can probably round this off to 6500 feet per minute. Look at the options and round, because you have done approximation already, and again you're trying to round off. So 6500 feet per minute. Now let's kind of do it in the basic way here. That so let's bring the gradient into picture. So we have the extended center line. This is the you know why it's a huge rate of descent? Because the gradient here, it's 12%. Right, so it's a huge gradient. That is why a slope. That is why you have a higher rate of descent. Right? So here, the gradient or the slope is given as 12%. Right? Now, what's the meaning of slope? So percentage slope is
V by H ratio into 100.
Into 100. That is basically the percentage slope. So this means that your vertical height is kind of 12% of the horizontal distance that you're traveling, right? And we have the ground speed here, and we have kind of derived the equation where it is equal to rate of descent in feet per minute divided by ground speed in knots. And in an attempt to convert these knots to feet per minute, we actually multiplied with 6080 feet, which will convert this nautical mile to feet, divided by 1 hour 60 minutes, and 60 minutes is going to go up. Therefore, it is 60 and then
into 100.
Into 100. Let's kind of substitute it here. Rate of descent is what is asked. You have 12. 100 is right there. Now, rate of descent is what have to calculate.
We need to calculate.
Into 6,000.
60
divided by.
Divided by ground speed. We are given 540 into 6080.
So what is ROD from this?
12 into 540 into 6080 divided by 6000. 6566.4. 6566.4.
That's right. 6566. So you can see
feet.
There is the obvious difference there. This is a more accurate answer, better one than that. But again, look out for this thing in the question before you kind of do this, or you can even try doing this and look at the options and kind of fix the answer. Right?
Yeah.
Is it clear? Will you be able to find out the glide slope here? That's not part of the question, but it's just I'm curious. I want to bother you. So, can you find the glide slope? I'll give you some time to burn your head. So the glide slope is z degrees. What's the meaning of that? You're losing 100 times
Height.
that feet every nautical mile.
Nautical mile.
Right? So you have a slope of 12%. On a 12% slope, what is going to be your height? What is going to be your vertical, the height corresponding to a horizontal distance of
1 nautical mile.
Yeah. So
It is 1200 feet.
that's right. 12% is equal to V by H into
H to 100.
right? So what they asked to find what V is. V is equal to 12 into H is 1 nautical mile. Nautical mile
Into 100.
divided by 100. H by 100. Now it's in nautical miles. Let's convert this to feet because we want it in feet. Therefore, it's going to be
Into 6,000. Sorry, yeah, 6,000.
6,600. So it's fine, right? What is
Yeah.
what is it here? 12 into 60. 720 feet.
720 feet.
Over 1 nautical mile. You see 3-degree glide slope itself is 300 feet every nautical mile. So it's like almost more than 2 times that you have to lose in 1 nautical mile. That's because for 3 degrees it's just 5% of glide slope, it's 12%. It's like more than twice, 10% plus 2%. You can see how it is falling in place. It's almost like same to same. So what is the you can instantly tell me what the glide slope is. If you have to lose 720 feet in how many nautical miles? 1 nautical mile.
1
What's the
nautical
glide slope?
mile.
Okay, we'll tell you the answer. You get the idea. 7.2.
Okay.
7.2 into 100. That's think the other way
Yes.
around? Yeah?
No.
So the glide slope is 7.2 degrees.
7.2 degrees.
So this question you can see we started off from a gradient, we went through rate of descent, and we also went through height on a glide slope, found the glide slope. So everything can be brought into a single question. It's not different, that's what I'm trying to say. You can interconnect all these things because it's all connected. Right? You can just copy this also. Very quickly find the glide slope.